Ramesh, can you explain do-while loops?
So we're talking about a loop, which is iteration, and the one we want to understand or talk about is do while. So let's take a problem that we want to address.
All right, I got one for you.
Okay.
All right, hook up a switch to PB1.
Okay. We
Yeah.
have a switch to PB1.
Yeah, hook it
Okay.
up. A positive logic.
A positive logic. So
Yeah.
there it is. There's our switch to PB1.
Okay, and now I want you to write code for me that waits until the switch is released.
Okay. Wait for switch
To be
On.
released.
PB1 to be released.
That's what I want. Can you do that?
Let's see how we can do it. Now, so let's first kind of gather our thoughts together, right? What we want to do is we want to read the switch.
Okay,
Right.
that makes it first.
We want to read the switch, read switch state. And then we're going to ask the question, is it released?
Okay.
Right? Is it open? Which is what is
Released.
released. And if the answer is yes, if the answer is no, we're going to go back and read the switch
okay.
again.
Yeah.
If the answer is yes, we're going to get out.
Yeah, that's what I want.
That's what we want. So the key thing to understand here is that this has to be done at least once.
Okay, yeah.
Right? We there's no point trying to check whether the switch is released without reading it. So we want to do this body, which we call the body of the loop, has to be executed at least once.
Got it.
So if I want to do something like that, I use a do while loop. So we convert this translates to, we say do,
Okay.
right? And we're going to read the switch.
Okay, so that's my body now coming
And
up.
that's my body. And the body of the code is I'm going to read into some variable called in, and I'm going to read my GPIO. This is GPIO B. It's on port B pin 1. So let's get the attribute in GPIO B, which is, this is a input pin. So it's a D in 31_0. And we're going to just isolate that bit, which is a 0x02.
All right, semicolon.
And semicolon, right? And we're going to check this and see, in our case, if this in, now we're going to say in, and we could be very precise and look for something else, but the good news is we're just looking for 0. If it's not equal to 0, then we want to go back and repeat this process, right? So it's a do while in is not equal to 0, we go back and repeat this process. Now, this is a natural way to think of this situation, simply because we know that we have to perform this operation at least once.
Got it.
Now, just as a sidebar, you'll see how ugly this code can be if I were to not apply the logically natural way of thinking about this. What would I do? Well, this is the clumsy way of doing it, which is somebody who knows a while loop and says, I'm going to use a while loop because I know that's what I've learned. So what do? You know you're going to read it at least once. So what you're going to do is you're going to first read it. You're going to read the switch up here. And you're going to do a while check here, right? And then you're going to read the switch again here before you go back and do it. Now, this works, but it's just not a natural fit for the way we want to perform our operation. The more natural way is to do this.
So the trick is to choose the format that is most natural.
Most natural. And this is what we generally do. In fact, in assembly language, we generally tend to do this, where we know we're at least doing one, so we just have a branch back to the beginning and then we check the status again.